Teachers, welcome. You're here. It's Innovate 21 and it's math day. And what are we going to start out with? How about a little subtraction of integers? You interested? You should be. This is pretty cool. Thanks for being here, everybody. What we're going to try to do today in a very short amount of time, we know your time is valuable. We're going to show you subtraction of integers. Now, why subtraction of integers? Why not? We really don't have a good answer to that. But what we do know is we get flooded with questions and emails every day here, and all of us teachers get together and we start talking about what should we start with, what should we do, and most of the emails come in and say, I really need help with the basic stuff that we do at the beginning of the year that my kids always seem to struggle with, and then it kind of snowballs on them as the year goes on. So we figured, why not subtraction? Well, you know as well as I do as a math teacher, if you give them a whole bunch of addition problems to do, they'll probably get most of them right. But if you get them a whole bunch of subtraction problems to do, especially with integers, they'll probably get half of them wrong. And all that does is have a negative impact as things go on. And so we're going to start with subtraction. Hopefully you love it. And then we're going to go up from there wherever we want to go. So if you get on Facebook, come here, leave us a comment. Tell us what you need. Tell us what you're struggling with. We'll put a video on for whatever we got. But we can take this to any level that we want. So I want to show you how we do subtraction of integers. And what we do is we start real simple. Remember the three principles that we have to go through. We have to build on some prior knowledge, so we close that gap of what they know and what they need to know. Then we're going to scaffold up slowly and logically so we keep the confidence and the success going in our class. And then we're going to move to the discovery aspect, where if there's anything that we really need to know as a rule, as a process, as a thing, we'll get to that, but we don't tell. The biggest thing you'll see about me and all the videos we do here of Innovate 21, we're not tellers of information. We're not just going to disseminate this information out to you. We're going to hopefully ask the right questions to lead the kids down the path to discovery, and everything we do from there is cemented in their brain. They have such an easier time of learning this. And I'm going to do it here with one of these. Why? Because I don't know all this fancy computer stuff to do it, like I see on YouTube. I think better with one of these. I act better with one of these. So you just get simple. Me, a marker, and a board. And that's all you get. And we're going to do it as quick as possible so you see.
Get ready! Woo!
The biggest struggle with subtraction is that students don't understand the math. They don't understand what the math does. Sometimes they can do the math, but they don't understand how the math is working. So we're going to attack it from that point. So when I start with my scaffolding and I start really, really low, so in my prior knowledge phase, you're going to see me do something that most kids are just going to roll their eyes. Now, I do this with high school kids, and I do it all the time, and they always moan and groan because they think it's too easy. Well, too easy and understanding it, not the same thing. So here's how I start subtraction. I start with subtraction, and not even with integers, just subtraction, and make it as easy as possible. I ask them to tell me how much that is. And here come the moans and groans. Okay, we got it, it's 2. And I'm with them. Excellent, it's 2. But now comes the teaching part. What I want to know from all of my math students is what they know. How do they think? So I'm asking right here, great, you got 2. Why did you get 2? And you'll hear a myriad of answers. Oh, because I know how to subtract, because I'm not stupid, because 5 minus 3 is 2. Okay, great. But why is it 2 specifically? Why isn't it 1? Why isn't it 4? Why isn't it 1.7? Exactly why it's 2. I'm asking these questions because I want them to know that the concept of subtraction is to make something less. I start with something, I take away, I want to make something less. I'm leading them down that path. So I'm asking them with a silly problem and a silly question, because if they cannot verbalize, or if they cannot explain their math with evidence, then they're no good to me. Then they'll never be successful on a standardized test. They got to be able to do it. So start with something simple. Give them some success. Here we go. 5 minus 3. Everybody knows it's 2. Cool. Why is it 2? And when I hear their answers and somebody will say, well, because I'm taking away. Excellent. Now we're getting something. Take away. Love takeaway. I start with 5. I take away 3. I'm left with 2. Awesome. So I need them to see that 2 is 3 less than 5. Look, it even says it right here backwards. 2 is 3 less than 5. Pretty cool, right?
Woohoo!
I need to drive that point home. They need to understand the concept that subtraction is making something less. Tell me what you started with, tell me how much you're taking away, and tell me what you end up with. And that thing that you end up with should be less than this thing. Seems pretty simple, right? Cool, so let's get another piece of evidence so we know. So we go, all right, what's 11 minus 6? Go. Now the kids, of course, high school kids catch on really quick. It's 5 because 5 is 6 less than 11. Oh, awesome. But why? But when we write 5, we want to know why. Because when I have 11 and I take away 6, I better end up with something less. Good. Make sure that point is cemented. The concept of less is not really ever taught because we go right to the formulas. All math teachers have committed the sin where we go, here's how we subtract. If the number is minus, change it to a plus and add the opposite and keep change, or whatever those silly rules are. But we go right into a rule and we make a kid perform a rule. Well, when they perform a rule, they get an answer, but they don't understand why the answer works. When it comes to the integer part, I want to make sure that they understand that the concept of subtraction is the same. So go back to the same problem. All with their confidence intact, we're making sure they're all feeling successful. We did 5 minus 3, we got 2, sweet. We did 10 minus 6, we got 4, I love it. But now let's go here. So now the subtraction of integers come in where I can say, how much is this? That's where I'm not instructing, I'm not telling them anything. I'm asking them how much it is. Now, am I gonna have a section of my class that knows? You bet. Shouldn't they all know? You bet. But do they? They don't. So you're gonna have some people that are gonna do it. This is the chance for you to walk around and gather the evidence. You're gonna hear me say this all the time. How do you know that your students know? Well, you got to go get some evidence. So let's walk around, let's check. Because you're going to see the kids that are right on point, and they're going to be putting -8. But you're going to know that out there in the classroom realm lives, well, 2 lives out there for sure. -2 for sure lives out there. And then you're either going to get one of these thrown in. Hey, I got 8. You got 8? Cool. I love it. 8. How'd you get 8? Well, my teacher always told me that a negative and a negative makes a positive, so I got +8. See? Not bad logic. They're mixing the streams here, but the logic is there. If we show the kids that it's not that bad to tell me a guess, that it's not that bad to say, hey, this is what I got, but the question out of my mouth has to be, why did you get that? Or how did you get that? Because I want to see how their brain works too. And once I know how their brain works and how they think, I can kind of steer them through this water and make them see how the math works without telling them. I'm not walking in here and go, change this to a plus and make that one negative because everybody knows how to add, so let's just teach them how to add. No.
No, God! No, God, please, no! No!
Let's teach them how to subtract. Let's teach them this concept of less. All right? So now when we got all our answers on the board, and by the way, I put all the answers on the board. And so you researchers out there that said, well, I read research that you shouldn't do that. Well, there's plenty of research that says you should. Okay? So here's what I'm going to tell you. When a student feels defeated, when a student thinks they don't understand, they will stop working for you. In math, we're trying to build the confidence, not squash the confidence. So here's what a traditional math teacher would go. Hey, 5 minus 3, somebody would go -8. They'd go, excellent, cool. Everybody got it? Any questions? Anybody not understand? Are we good? Huh? We're good. We don't see any hands go up. We go, wow, they must understand it. And the reality is, no.
No!
That one kid over there understands it, but not everybody understands it. This is why the walk around through the class is a huge deal. You need to see who doesn't, who can, who can't. You need to know what your students know. So we're going to go find out. And now when I come back up to the board, I'm going to say, what did you get? And as soon as I write this, if I say, yes, that's the right answer, the kids that didn't write that, pencil goes down. This is why I hate math, because I don't understand. I didn't get -8, but he said the answer was -8, so I guess I'll be failing math again. No, my answer is -8, cool. Did anybody get anything else? Nobody got anything different? I know I saw a couple. Alex, what did you get? Eddie, what did you get? I know you guys got something different. I've done that research already. I've seen what they've done, and I'm putting up the answers. And a lot of times when -8 is the first one called out, I go, -8? And now all of a sudden the kid that didn't get -8 go, maybe my answer's right. Maybe it is. Let's put it up there. Well, he's got it up there. So now I can see all the brain power. I got kids up there, and I even might take a vote. Anybody else getting 2? Oh, a couple more people got 2. And I'm, ooh, nice. Anybody else get -2? And then sometimes when there's not a lot of checks here, and there's a whole bunch of checks here, the students start self-evaluating and go, I'd like to change my answer. And then my first question is, why do you want to change your answer? Because everybody else is saying this? What if that one's wrong and you're the only right one in the class? No. I refigured out. Well, good, because now we're starting to understand. But now, once this is all up, we have to go back and say, why? Okay? We have to know what they know. So the scaffold has got to hear, but we still need them to verbalize, with evidence, why. So the question is, which one of these answers do you think doesn't belong? And I'm going to take a suggestion, but then the question is, why did you say that? I'm looking for the knowledge of math here. And again, we're going back to, if I start with a quantity and I take something away, the answer is something less. Okay? Now we're just talking about straight up subtraction here. We're starting with a quantity, take something away, you end up with something less. So I come back to the problem so we can see. Do you remember the concept of less? We remember, yes, okay. I'm starting with -5. Starting with -5. Then I'm taking away 3. I should be getting an answer that is less. Is 8 less than -5? Keep in mind, my prior knowledge and everything brought into this lesson to this point in time means I've already talked about the concept of negative versus positive, greater versus less. If you didn't do that the lesson before, they're going to have a whole bunch of trouble with subtraction. So I don't know if you follow textbooks or anything you do like that, but make sure comparison of 2 integers is done before you do subtraction, because they will have all kinds of problems with that. Okay, so now I can ask the student, if I have -5 and I get an answer as 8, is 8 less than -5? Is it less? And usually that's pretty obvious, and go no. And it's like, okay, so it's not less. So that whole business of a negative and a negative making a positive, does that make sense here? No. Well, we'll talk about that later, but see why it doesn't make sense. I gotta be less. So if I have -5 and I take away 3, am I gonna get 2? Is 2 less than -5? And obviously the answer is no, but we want to hear from those students. Well, it is? Okay, but we're going to go through all the talk if they say it is, but hopefully they don't. And we'll show them if they think it is. And then we get to -2. Notice, I'm not just jumping to the right answer and acknowledging the right answer and defeating everybody else's. I'm trying to get everybody to see, if they wrote one of these wrong answers, why the thinking is bad. Not why the math is bad. We already know the math is bad. So now we got to get their thinking to be straight, all right? -2. Is -2 less than -5? Well, that's the hardest one to deal with, right? So hopefully we've come through and we understand that -2 is closer to 0, or however you wanted to say it, or -5 is farther to the left in the number line. However you made your students verbalize value in numbers, that's what you want to pull out from them, and they go, no, -2 is not less. So this could be a good example of the answer. All right, so that's the basic premise. Now, I'm going to do several more of these basic ones, but I'm going to try to shorten this video and show you that you need to make sure it's cemented. So the next one I do is another evidence gatherer for me, so I can go, yes, they're starting to understand this concept. So I just jump right in and I might go negative 13 minus 12. That's one of my favorite ones right there, negative 13 minus 12. And why negative 13 minus 12? Because sometimes the answer 1 and negative 1 pops in their head right away. And not that that's bad, I want them to see that that cannot be the case. So you'll have your students for shouting out, negative 25, cool. And my question is, again, why is it negative 25? I want those confident students to tell me. They're confident in the answer, they're right. Okay, so tell me, why is it negative 25? And here's the answer I got. Well, it's negative 25 because I know how to subtract. Okay, cool. Why did you get negative 25? Well, I added those two together. Oh, you did? Oh, nice. You added them together. Why did you add? Because if they say, well, that's what my teacher last year told me to do, go, no, that's not how math works. I want to know why'd you add. Because this clearly says subtract. So why did you add? Now they stumble on that question. That's the verbiage and that's the vocabulary that we got to get. That's the evidence they're going, I don't know why I added. Well, if I'm at negative 5 and I'm taking away 3 more, negative 6, negative 7, negative 8, I'm going less, I'm going farther to the left in the number line. So wouldn't it make sense if I'm starting with negative 13 and I'm taking away 12, I'm getting a number that's less. So I got to go negative 14, negative 15, negative 16. I got to go 12 spaces to the left. That's how I get to negative 25. I made a number less, started with an amount, took away, got an answer that's less. Okay? Now, usually in a math lesson, this next question is, well, so can't you just add them? I don't know. Does that work every time? I don't know. Let's try it. Give me a number. How about negative 11? Cool. What else? Minus 8. Cool. If I'm on negative 11 and I take away 8 more, I got negative 11, I'm taking away, I'm making it less, I'm moving to the left, where am I going to end up at? And hopefully we all shout out negative 19, and then I go, did I just add those two together? Did I write positive 19? No, why not? Because the answer needs to be less. Oh, okay, so I got to make sure I stay on the negative side of the number line. Yes. So does this always work? Now see how we get to it? I didn't tell them this rule, but see how we're getting to it? So now we can say, is there something we can write down to memorize so we remember that we can just add them? Because isn't 5 and 3, 8, put the negative sign, 12 and 13, 25, put the negative sign, 11 and 8, 19, put the negative sign? Yeah, that's true. We just figured it out. They're all less. We did it. We got it. But is there some way we can write that so we can go get to it right away? There's the famous rule that we all got to teach, right? But we're going to discover the rule. I didn't just tell it to them. So I'm going to put it in their words. What do you think we should write? And they're going to say, add the two together. I'm going to go, add what two? Just any two? Because what if my problem is this? Or what if my problem is this? Do I just add those? No. So what's the difference? Because here I'm getting negative 1, here I'm getting 2. So what's the difference between these two and these two? How come there I added and how come here I subtract? Do you see? And so in the interest of time, I'm not going to go through all the examples, but I do a lot of these. I do a lot of these just to make sure. And then I take away the negative sign. And then I go, does our rule work anymore? Oh no, because if I'm on 8 and I take away 9, I'm going to get less, but it ain't 17 less. So do you see how I work them through this? But I want them to put this rule in their own words. Hey, if the first number's negative and you subtract, you're allowed to add those two together. Okay, cool. But this first number isn't negative. So did I add those two together? No, I subtracted. So did I make my answer less? Yes. Is negative 9 1 less, or is 9 1 less than 8? And the answer is yes. So I see how I slowly bring them to that. So in the interest of time here in a video, I'm not going to go through all of the issues, but this is where subtraction is the hardest part for them to understand, because they don't understand the concept that's allowing the numbers to subtract. We're going to get to the rules about when you add them and when you subtract them when we hash this all out, but I'm making them do this problem first. I'm walking around, I'm seeing what answers they get, I'm writing all those answers on the board, I'm asking them why. I'm at 3 questions I always ask. Why? How did you get that? And does anybody in class get something else? Did anybody in class get something else? I want to know what else is out there. What other answers live out there? I'm checking. I'm constantly drawing that evidence. I guarantee if you approach it from this aspect about subtracting, now we can get into the double negative thing and all that kind of stuff in another video, but in the basic interest of subtraction, it's less. I'm taking away, I'm pulling away. It's counting to the left, and however you want to do it, but you want to make your students verbalize that. You want to make them see it. Start with something easy that they can do. Make sure they understand how to explain it to you. Remember, evidence, evidence, evidence. Then you scaffold up. Keep putting in another one. Practice, 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 so they understand, and then go, let's write the rule for that. We usually teach that backwards. Here's the rule, let's try it. Well, learning never happens that way, because we've all plugged in the same address into our GPS more than once, because we didn't learn, because the little computer just told us turn left, turn right, turn left, go straight. We didn't learn anything. Well, when you teach them a rule or a process like that, the same thing happens. They don't learn. They do it, they get the right answer, but a lot of times they don't understand. And when you ask them, why did that happen? And they can't tell you, that is the kid telling the teacher, I don't get this. Even though I got the right answer, I still don't understand, because when this gets a lot tougher, they're going to have to apply this knowledge. And once they can't apply it, then they can't pass standardized tests, and it all snowballs from there. Teach your kids how the math works. Don't just teach them the rule. We're not tellers here at Innovate 21. We're discovery-based teachers. Hope you thought this was worthwhile. Leave me some comments, go on the Facebook. I can explain it to you in further detail, but it's one of those teachable things that you can put in, and I guarantee you will have an effect on your class. Believe me, try it, and I'll see you next time. Innovate 21, it's discovery math. It's a piece of cake.